Dear students, I welcome you in this lecture from the chapter Linear Programming Problems. In this lecture, we are going to solve some examples on minimization type of linear programming problem. Let us see some examples. Here, we are going to solve the linear programming problem. Minimize z is equal to 4x plus 5 subject to 2x minus y is greater equal to 4, 2x plus 3y is greater equal to 12, x is greater equal to 0 and y is greater equal to 0. Any linear programming problem has three parts. So first part is optimization of objective function. So first part is objective function and it is to be minimized or maximized. In this case, we are considering the problem of minimization. So objective function is z is equal to 4x plus 5y. Second part is of linear constraints. Second part is of linear constraints. And third part consists of non-negativity. Third part consists of non-negativity constraints. Non-negativity constraints assure that solution of linear programming problem lies in first quadrant. So, due to non-negativity constraints, solution of linear programming problem is always in first quadrant. It is not going to be in second, third or fourth quadrant. It is going to be in first quadrant only. We are going to solve this linear programming problem by graphical method. Graphical method has several steps. So let us see how can we solve this linear programming problem by graphical method in step-by-step manner. First step is to plot the lines. So first step is plotting lines for linear constraints. Which lines we have to plot? Note that z is equal to 4x plus 5y is not equation of line. So we can't plot this as a straight line. Secondly, the lines corresponding to these constraints x is equal to 0 and y is equal to 0 are already plotted. They are nothing but y and x axis respectively. X is equal to 0 represents this x axis and x is equal to 0 represents y axis and y is equal to 0 represents x axis. So y is equal to 0 and x is equal to 0. These are nothing but x and y axis. So they are already plotted. So which are left? Two are left. 2x minus y is less equal to 4, greater equal to 4 and corresponding equation of line will be 2x minus y is equal to 4 and corresponding to the second constraint the equation of line will be 2x plus 3y is equal to 12. So we have to plot these two lines. 2x minus y is equal to 4 and 2x plus 3y is equal to 12. How to plot lines? We have already seen this in first lecture. In case you have not watched the video for first lecture or you have not studied it, I'll request you to go through that so that you will understand how lines are plotted. Now let us plot these lines. So first we will plot the straight line 2x minus y is equal to 4. Point on x-axis is given by c upon a, constant upon coefficient of x. So 4 upon 2, that is equal to 2. So this is how where we get point on x-axis. Then point on y-axis is given by point on y-axis is given by 4 upon coefficient of y, which is minus 1 here. Minus y means minus 1 into y. So 4 upon minus 1, that is equal to minus 4. So let me plot this here. Say minus 5 I put, and I will graph it once again. So the point which we get on y-axis is minus 4. Here you can see it is point minus 4, and point on x-axis which we obtain is 2. So this is 2 and this is minus 4, this point. We draw a line joining these 2 points. 2 points determine a line. So this is the equation of line representing the equation 2x minus y is equal to 4. So first equation. Now second line we will plot. So the first line was corresponding to this constraint, and now second line we are going to plot corresponding to the second constraint. Second constraint is 2x plus 3y is greater or equal to 12, and corresponding line is 2x plus 3y is equal to 12. So point on x-axis is given by constant upon coefficient of x, 12 upon coefficient of x, which is 2. So 12 upon 2, which is equal to 6. So here is the point 6 on x-axis. On y-axis, the point is given by constant, which is 12 upon coefficient of y, which is 3, 12 upon 3, which is equal to 4. So this is the point on y-axis. So 6 and 4. Now you can observe we have 2 points, so we can join them and get the line. This line in green color represents the straight line 2x plus 3y is equal to 12. So first step is over of plotting lines. Second step is to determine common feasible region for linear and non-negativity constraints. So we have to determine common feasible region satisfying all linear constraints and non-negativity constraints. Due to non-negativity constraints, x is greater or equal to 0 and y is greater or equal to 0, solution lies only in first quadrant. We have already seen how to determine feasible region for inequalities or linear constraints. In case you have not gone through that video, I will request you to go through that video so that you will be able to understand how we are going to determine feasible region for each of the constraint and then finally decide the common feasible region. So let us determine common feasible region for linear constraints. First we consider the constraint 2x minus y is greater equal to 4. So this is first constraint that we are considering. Any line divides the plane in two parts, origin side and non-origin side, if the provided that line does not pass through the origin. So if origin satisfies the constraint, then we shade the origin side. If the origin does not satisfy the constraint or inequality, then we shade non-origin side. So put here x and y as 0 because we are determining whether the inequality is getting satisfied by origin, which has coordinates 0, 0. So 2 into 0 minus 0, that is 0, is greater equal to 4. So if 0 is greater equal to 4, whether this is true or false, it is clearly false. 0 is less than 4, so it is false. And if it is false, then we shade which side of the line? We shade non-origin side. We shade non-origin side. So first line 2x minus y is greater equal to 4. This is the line. This line. So 2x minus y is equal to 4. It is represented in red color here. And we have to shade the non-origin side. This side is origin side because it contains the origin. This another side of this line is non-origin side. Okay. So non-origin side, I am going to shade it by ticks for first constraint. So I am going to shade it by ticks of this. So one more thing, you can, as we want the solution in first quadrant due to non-negativity constraints, we can simply shade only the in first quadrant. Okay. So let us concentrate on first quadrant only. So first quadrant is this. Okay. It is optional to write this. Now we are going to determine the feasible region for second constraint. The second constraint here, it is 2x plus 3y is greater equal to 12. Again put x at 0 and y at 0. So 2 into 0 plus 3 into 0 is greater equal to 12. So 0 is greater equal to 12. This is false. And if the condition that we are checking is false, then we shade which side? We will shade non-origin side. We will shade non-origin side of this line. So this line, which is represented in green color, it is the line 2x plus 3y is equal to 12, and which is the non-origin side, which does not contain the origin. So this is the non-origin side, and as I mentioned, we can concentrate only in first quadrant. So I'm going to concentrate only in first quadrant here for this part. Okay. So which is the common feasible region? The one which contains cross as well as ticks. So this part we can't consider because it doesn't contain ticks. This part again we can't consider because it doesn't contains cross. So whatever is shaded in white color, that is the common feasible region. This part is common feasible region. Let me erase everything so that you will get what exactly is common feasible region. So this is the common feasible region which is obtained. This part is common feasible region. Third part is to determine vertices of common feasible region which we have obtained. So in first step, we plotted lines. In second step, we determined common feasible region. Now in third step, we have to identify vertices of feasible region or common feasible region which we have obtained. It is shaded here, as you can see. It is shaded here, this portion. So we have to obtain vertices of common feasible region. As you can see, it has got two vertices. So this is first vertex and second vertex. Let me call this as B and this as A. So while plotting lines, we have determined point coordinates of point B. It was 0.6 on x-axis. So B has coordinates. This is point B and it has got coordinates 60. So point B has vertices or coordinates 60. Now the question is how to obtain coordinates of point A. It is intersection point of these two lines. 2x minus y is equal to 4 and 2x plus 3y is equal to 12. So in order to obtain coordinates of point A, we have to use the formula. We have seen this formula for obtaining intersection point of two lines. In case you have not gone through that video, I'll request you to go through that video in which we have studied how to determine intersection point of two lines algebraically. So let us see how can we determine the intersection point of these two lines. Here we are having two lines. 2x minus y is equal to 4 is first line and second line is 2x plus 3y is equal to 12. So 2x minus y is equal to 4 is represented in red color here. 2x minus y is equal to 4 and second line which is represented in blue color, it is 2x plus 3y is equal to 12. Okay, so we have these two straight lines and the problem is to determine the coordinates of intersection point, say A. We'll write corresponding coefficients for first line. Value of A1 is 2, value of B1 is minus 1, value of C1 is 4. So here value of A1 is 2, value of B1 is minus 1 and value of C1 is 4. Now values of A2, B2, C2. So value of A2 is 2, value of B2 is 3 and value of C2 is 12. So A2 is equal to 2, B2 is equal to 3, C2 is equal to 12. The formula for x coordinate of point A is x is equal to C1B2 minus C2B1 upon A1B2 minus A2B1. This is the formula that you have to remember. So just substitute the values of A1B1C1 and A2B2C2 in this formula and verify that you get x is equal to 3 or not. You pause the video for a while, do the calculations on your own and see whether you get x is equal to 3 or not. Similarly, the formula for y coordinate is y is equal to a1c2 minus a2c1 upon a1b2 minus a2b1. Denominator is same. So no need to repeat calculations for denominator. once you have done it for x coordinate. Again substitute values of a1 b1 c1 and a2 b2 c2 and see whether you get y is equal to 2 or not. Geometrically you can see that this point is 3 and here it is 2. So 3 and 2. A has the intersection point has coordinates 3 and 2. This is how we determine the coordinates of intersection point of two lines. Let us come back to linear programming problem. So, thus we have seen that coordinates of point A are 3 and 2. We are having 2 points B and A. A has coordinates 3 and 2 and B has coordinates 6 and 0. This is the third step. We have determined two vertices of feasible region. Feasible region may have two or more vertices. In this case, we are having only two vertices as it is unbounded feasible region. It is not bounded, it is unbounded here. You can see it is unbounded in these directions. So it is unbounded feasible region and it has only two coordinates A and B. This is not coordinate. This is also not coordinate. This is not vertex of common feasible region because common feasible region is this one only, which is shaded in white color. Now, the last step of solving linear programming problem, which is the fourth step, is values is to determine values of objective function at vertices of feasible region. Values of objective function at values of objective function at vertices of feasible region. So what was the objective function? Recall that objective function is z is equal to 4x plus 5y. So objective function is z is equal to 4x plus 5y. Let us determine value of this objective function at two vertices A and B. A is having coordinates 3 and 2. So substitute x is equal to 3 and y is equal to 2. So 4 into 3 that is 12 plus 5 into 2 that is 22. So 12 plus 10 equals to 22. So at point A we are having the value 22. At point B we are having the value as point A has coordinates 6 0. So it is going to have the value 4 into 6 that is 24 plus 5 into 0 which is, so it is going to have the value, it is going to have the value 24. Okay, so 24 plus 0, 24 plus 0 is the value. Let me correct it here. 24 plus 0, that comes as 24. So z is equal to 24 is the value. Now what was the problem? The problem was to find minimum value of objective function. The objective function was z is equal to 4x plus 5y. So out of these two values, one value is 22 and another value is 24. So out of these two values, 22 is minimum. Hence, the final solution of linear programming problem is objective function z is equal to 4x plus 5y, z is equal to 4x plus 5y has minimum value 22 has minimum value 22 and it is obtained at the point, which is the point of minimum value corresponding to 22. It is the point 32, at the point 32. So final answer of the linear programming problem is that the objective function z is equal to 4x plus 5y has minimum value 22 at the point 32. This completes the solution of linear programming problem. Thank you.